equation 2y cubed plus y squared minus y to the power 5 equals x to the power 4 minus 2x cubed plus x squared has been likened to a bouncing wagon. It kind of does look like a bouncing wagon there. Okay, so it says find the x coordinates of the points of this curve that have horizontal tangents. Notice it just asked for the x coordinates. You'll see why once we start solving. So anyways, if I want to find where horizontal tangents are, what do I have to do? Where what equals 0? Yeah, where the first derivative equals 0. So first we have to find the first derivative, thus the implicit relations here. So what is the derivative of 2y cubed? 6y squared dy dx. So then y squared, what's the derivative of y squared? 2y dy dx. And then derivative of y to the power 5. Yeah, dy dx equals 4x cubed minus 6x squared plus 2x. Everybody good? Okay, can I state what dy dx equals in one step? Okay, so that's going to be 4x cubed minus 6x squared plus 2x all over 6y squared plus 2y minus 5y to the power 4. And so where is the horizontal tangent going to be located? Where the derivative equals 0. So how do we solve that? Yeah, so 0 equals that. But does it matter about the bottom here? No, because that would be cross multiplied over. Be gone. So we get 4x cubed minus 6x squared plus 2x. And we can divide by 2. And an x. So 0 equals, I'm going to divide the 2 and factor out the x at the same time. If you want to have the 2, you can. So we get 2x squared minus 3x plus 1. Yes? 0 equals x, 2x. So that's 1, 1, minus, minus. Yes? So that means x equals 0, 1/2, and 1. Again, it only asks for the x coordinates, and you can see why. If you actually look at this graph here, look at where it's 0. Do you see there's a spot, there's a spot, say there's a spot, right? If you look at 1/2, you see there's a spot, there's a spot, there's multiple y values, right? So that would be just crazy to solve after that. So that's why they're asking that way. All right. Good? Okay, example 2. Use implicit differentiation to find the points where the circles defined by x squared plus y squared minus 2x minus 4y equals -1 has horizontal and vertical tangent lines. So, first step, derive. So we get 2x plus 2y dy dx minus 2 minus 4 dy dx equals 0. Everybody good with that? Okay, do you think we can do this all in one shot? Maybe in 2, because we're going to have to divide by 2, unless you think we can just divide by 2 right now. What do you think? Am I going to go too fast here? Okay, so I'm going to move the 2x and the 2 over and divide by 2 at the same time. So it's going to be 1 minus x over, oh, I forgot a 4 there. Wait a second, that goes on the bottom. Never mind. See, I'm confusing myself now. So then it's going to be y minus 2. Very good. Okay, we good? Okay. So where is the horizontal tangent? Yeah. So 0 equals 1 minus x, so x equals 1. It's saying to find the points. So now that I know it's located at x equals 1, how would I find the coordinate? Plug it in, that's right. So I get 1 squared plus y squared minus 2 minus 4y equals -1. So I get y squared minus 4y. 1 minus 2 is negative 1. Plus 1 is 0. So that we get that, yes? And then we get y minus 4 equals 0. So y equals 0 and 4. Therefore, horizontal tangents at 1, 0 and 1, 4. Let's look at the graph here. 1, 0 and 1, 4. Look at that. Yes? Good? Okay, let's do the vertical now. Where do we find the vertical tangent? I'm sorry? Where it's D and E. So how do we do that? The denominator equal to 0. So the denominator was y minus 2. So that means y equals 2. Yes? How do I find where the x's are now? Plug it in. That's right. So x squared plus 2 squared minus 2x minus 8 equals negative 1. So x squared minus 2x, 4 minus 8 is negative 4, plus 1 makes negative 3, and then that factors beautifully. So x minus 3, x plus 1, x equals 3 and minus 1. So therefore, vertical tangents at 3, 2 and negative 1, 2. And if we look at the graph here, 3, 2, right there, and negative 1, 2, right there. So I just provided the graph there so you can see visually what we're actually solving. They, of course, on the exam would not do that for you. Okay, let's move this out of the way here. Consider the following relation, which is an ellipse. We've never seen an ellipse before, have we? It's kind of like an oval, except an oval is more flattened on one side than the other. Like this is a perfectly kind of. The difference between a circle and an ellipse is it's usually, you know, longer one way than the other, where a circle is the same radius the whole way. So anyways, this is an ellipse with center 0, 0, and the equation 4x squared plus 9y squared equals 36. Justify the intervals where the relation is decreasing and increasing using the first derivative. Okay, usually they won't tell you the first derivative. They'll just... Yes, we're going to do a sign diagram in a second. But it's kind of complicated with implicit, though, because it's not really. Okay, so first things first, derivative 8x plus
18y prime
dy dx equals negative 8x over 18y, which reduces to negative 4x over 9y, yes? Okay, so where is the critical points here? Right, because the increasing, decreasing will have to do with, we have to figure out where we need to, you know, get some intervals here. So yes, where it's 0 or doesn't exist, yeah. So we're going to set it equal to 0. So 0 equals negative 4x. So that means x equals 0. Okay, so this is implicit. So the y value is important here. So once we get something, we have to plug it in. So we get essentially 9y squared equals 36. So y squared equals 4. So y equals plus or minus 2. So at 0, 2 and 0, negative 2, do you see? We found some pretty critical points there on the graph. Okay? Yes?
Yes.
Okay, so now we're going to find where it's undefined. Undefined is where? So 0 equals 9y, so y equals 0. So then we're going to figure out where the x coordinates are. So that is 4x squared, is 0 is the y, so equals 36. So x squared equals 9. So x equals plus or minus 3. So you can see that's this right here and here. Okay, so how, I know you can look at the graph and you can tell where it's decreasing and increasing, but how do we actually justify it? Yeah, we use the derivative and we do what with it? Well, usually on a sign diagram, we would pick something in the middle of it, right? So we figured out that these are critical values. It happens to be on the actual x and y axis. So we need to pick something between, say, for instance, 3, 0 and 0, 2. So pick something, 1, 1. Okay, so we're going to test 1, 1, right? And if I put 1, 1 in there, what do we get? Negative. Okay, what's something between 3, 0 and 0, negative 2 there? 1, negative 1. So 1, negative 1, what do I get there? Positive. Okay. Then pick something between. So basically you just have to pick. So does everybody understand that you have an x value of negative 3 and 0. So you got to pick something between negative 3 and 0. And something between negative 2 and 0. So that's why everybody's picking the 1, 1 or whatever, negative 1, 1. So in this one, negative 1, negative 1. So what do we get? We get negative. And then if we pick, say, negative 1, 1, it's going to be positive. It's a pattern, that's right. Okay, so now this is, how are we going to actually say this? If you didn't have the graph provided, I would probably just plot this really fast, right? You know what I mean? Like, so this is 3, 0, this is 0, 2, this is negative 3, 0, and this is 0, negative 2. And then again, you need to pick something between here and here and here and here. So something in that kind of square as a point, and then test it in your derivative. Okay? So how do we answer this question here? Okay, so let's say it's increasing where dy dx is greater than 0, yes? So that is when x is between 3 and 0 and y is between negative 2 and 0 at the same time. Yes? That's the quadrant 4 one, right? And then I'm going to say as well as when it's also positive when x is between negative 3 and 0 and y is between 0 and 2 at the same time, right? Now we got to say where it's decreasing. So decreasing where dy dx is less than 0. So that is when that was negative when x was between 0 and 3 and y is between 0 and 2, as well as when negative 3 is less than x is less than 0 and negative 2 is less than y is less than 0. All right. Okay, so anyways, we need to figure out where the curve is, the concavity of the curve where y is greater than 0. So, how do we find concavity? Okay, so 2x plus 2y dy dx equals 0. So dy dx is going to equal minus x over y, yes? If we divide by 2. Okay, so then concavity has to do with which derivative? Second. So we're going to go d squared y over dx squared equals, what do we do here? Quotient rule. So the derivative of negative x is negative 1, and then times y. And then we're going to subtract, right? Subtract, but then we still have a negative x, so it's going to be plus x dy dx over y squared. Do you remember our quotient rule?
Oh.
So then, do you remember what we're not supposed to leave it like this? Yes, we need to substitute that in. So we get negative y plus x times negative x over y squared. We can't leave it like that. That's crazy. So we need to do negative y, and then this is going to be minus x squared over y, all over y squared. So what do we have to do to get this together? Common denominator. What's my common denominator? Y. Yeah, so y over y. So then this becomes negative y squared minus x squared over y squared. And what's the little trick? Yeah, keep change slip. We'll slip that down. So our final answer is going to be negative y squared minus x squared over y to the power 3. Okay, so now we need to set that equal to 0. The problem is this looks a little complicated. Hahowever, crazy thing, if I actually take this, do you see x squared plus y squared equals 36? What happens if I make this negative x squared minus y squared? What would that equal? Negative 36. So that simplifies stuff if I put that in. So that is negative 36 over y cubed. Saying y has to be greater than 0. So if y is greater than 0, do you see? It's saying in the question that y has to be greater than 0. So if that's the case, if we have a negative 36 divided by a positive, what is it going to be? Therefore, d squared y over dx squared is going to be less than 0 everywhere, right? Do you see that? Oh, I shouldn't say everywhere. I should say only where y is greater than 0. Where y is greater than 0. So what does that mean concavity-wise if it's negative? No, we're just got to concave down. Concave down. Down. It's not asking about maxes, though. It just wants concavity. So concave down where y is greater than 0. So let's just look at this graph. Look at that, where y is greater than 0. Do you see that? Looks like concave down. Yes. Okay, so this actually was taken from the 2018, it's kind of an edited form of the 2018 question that was on the exam. Anyways, consider the following relation: 3x minus y equals 4 plus 3 cos y. Justify where the relation is increasing, decreasing, and concavity for negative pi over 2 to pi over 2. So how do we figure out this? Okay, but how do we do that? We got to find the derivative. So, okay, so does everybody understand? You could actually multiply the 3 in, and you may want to do that first just to make it simple. It's up to you. Or you can just scooch the 3 over and have it out. But in the end, you're going to have to multiply it in anyways. So I'm just going to pre-multiply it in here, so then when I find my derivative, it's just a little easier. So derivative of 3x is 3. The derivative of minus 3y is minus 3 dy dx, yes, equals the derivative of 4 is 0. The derivative of 3 cos y is negative 3 sine y dy dx. Okay. Are we good so far? Okay, so now we're going to solve for dy dx. Can we do this all in one step, or yes? Or maybe we shouldn't? I don't know. We shouldn't, or we should? We should. Okay, let's go for it. So dy dx. Okay. I'm going to move this over, right? So I'm going to have 3. Do you see the 3's? All the 3's can cancel, right? 3, 3, 3. So we're going to have 1 over 1 minus sine y. Did I lose anybody by doing that? Okay, so critical point. For it equals 0 or undefined, so it'll never equal 0 at the top. So 1 minus sine y equals 0. So 1 equals sine y. So y equals where is y then? Where's
1 over sine y.
pi over 2, yeah. But pi over 2 plus 2k pi, where k is an element of the integers. Yes? The domain is for the concavity here. Yeah. So what do we do here? We're going to do a sine diagram. We're going to put pi over 2 here. And there's going to be a pattern. Okay. So what do we want to pick here? What's on the right of pi over 2?
Pi 1.
Pi? What's sine of pi?
Pi 0.
0, 1. So what do we get then? And on the left, what do you want to pick?
Negative 0. Pattern.
Actually, you know what? Maybe I should actually do it for sorry.
Oh, now I got to rate.
Stop it. We're going to do it between negative pi over 2 to pi over 2. Okay? Because, okay, so pick something between negative pi over 2 to pi over 2. 0. So what's sine of 0? We should know. Sine of 0? 0. 1 minus 0. 1. So we're going to get positive. So what does the positive derivative mean then? Therefore, is it increasing or decreasing? Okay, since dy dx is greater than 0, the relation is increasing from, I guess, negative pi over 2 to pi over 2. Okay, so now how do we do concavity? Second derivative. So we got to use the first derivative. I don't know if I can see it here. So d squared y over dx squared equals. So how do you want to deal with this one? I know a lot of people want to do a quotient rule, but it's not really a function on top. So what's easier? Yeah, write this as 1 minus sine y to the power negative 1. So then this becomes negative 1, 1 minus sine y to the power negative 2 times, the derivative of 1 is 0, the derivative of minus sine is, well, it's going to be minus cos, right? Minus cos y dy dx. And then what do we have to do then? Plug her in. So I'm going to, before I plug it in, I'm going to deal with this. So d squared y over dx squared equals, I'm going to put this on the bottom here. So 1 minus sine y, that's going to be squared. Does everybody see what I did there? Okay, so then this negative negative is really a positive, so I'm actually going to get rid of the negative. So then I have cos y, and then instead of dy dx, my dy dx is 1 over 1 minus sine y. So what's the trick there? You bring her down, yeah. Well, it basically, when you multiply those together, the cos goes on top and this slips down. So this is going to be cos y over 1 minus sine y, the whole thing cubed. Yes? Okay, so now we got a test between, right, so, sorry, I didn't actually label this f prime. We should f double prime. Just so we can tell the difference. So this is negative pi over 2, and this is pi over 2. So let's pick a number between those.
0.
Yes, let's do 0. So 0 we get, cos of 0 is 1. And 0 on there we get 1. So we get, well, sine of 0 is 0. So we get 1 minus 0 is 1. So we get 1 divided by 1. So positive. So what does that mean? Yeah, therefore, f. Oh my gosh. Okay, d squared y over dx squared is greater than 0. Relation is concave up, where y is between negative pi over 2 to pi over 2.